our next piece, we're going to cover a little bit out of chapter 4. So we are not doing the whole thing. We'll do the first 3 sections. And then that'll be at the end of our second unit. So we're probably looking at a test, not this week, but next week sometime. First thing we're talking about is scatter plots. We aren't going to do a ton of with this. In general, scatter diagrams, you guys have probably made those before where you have an X and Y axis and you're just putting dots to represent all your points. When we make these, we're pretty much always going to do it on the graphing calculator because we're worried about getting a line of best fit and those kinds of things, and we'll use the calculator for all of that anyway. So we're really not going to focus on doing it by hand, more using the technology to help us. So just some clarification, we have response and explanatory variables. So the response is essentially like your Y value, that's the thing we are measuring. The explanatory is like our X value. So a scatter diagram is when we make a graph for those. We have our X and Y values. We label them, make sure when we set that up, if you were to draw one by hand, you would need to put units, labels, what each axis represents. So we're just going to jump right in and try one. I think we may have even used this example for something else previously, but we want to determine the time it takes to dry drill a distance of 5 feet in rock. We want to see if it increases with our depth. So here's our X and here's our Y. We are going to put this in our graphing calculator. And when you do that, you are going to put all of your X's in L1 and all of your Y's in L2. Now, it is a little more important how we put these in. If you skip a value, you can't just put it at the end because now these are essentially ordered pairs. So you have to make sure they line up. So once we have these listed, if we go into second, our stat plot, I'm going to go into plot number 1. I want to turn it on, and the scatter plot is actually the first option in this type. So we've been here when we did box of whiskers and histograms. We want the scatter plot now as the first one. So then you need to watch on your calculators. We might have to change something. Your X list should be L1. Y list should be L2. So if it says something else, if you do second, the number 2, that'll set that. Okay. And then if we go to zoom, number 9, it will zoom us to wherever our data is at. And so we should see a scatter plot then. Homework, several of the questions are going to ask you to make a scatter plot. If you just draw me like a really, really rough sketch like this, just showing the general shape, what it looks like, that's fine. I'm not really going to make you draw on your paper the X and Y axis and put all the dots. Okay? Yeah.
How'd you get
If your window's weird, Zoom 9 will automatically zoom to wherever it is. Okay, one of the big things that we're looking at with this is what the shape of our data is. And there's various things we might look at. Ideally, we want linear, so that means our scatter plots kind of look like a line, which is probably, algebra classes, you probably talked about lines of best fit. So if we look at this, we're checking, does this look like it's somewhat linear? There's positive and negative linear relationships. So if it would be a positive slope, increasing line, that's a positive linear. Decreasing is negative. It's also possible that there might be a relationship, but it's not linear. What kind of graph would this one be? A quadratic. So you can't say there's no relationship, but it's not a linear one. This one looks more like it's a cube or something going on in the middle, but it's definitely not linear. It's also possible that you might just have a random assortment of dots and you can't really tell what it is, and then we might say that there's no relationship whatsoever. So one of the first things we're going to do is kind of look at our scatter plots and see, could this be a linear relationship or not? So the one we did, does it look like it could be linear? Yeah, positive or negative? Positive, because it's increasing. Okay, so then, ideally, we want to know, like, how, if we got an equation for a line, how good of a model would this be? And so there's a couple things that go into that, but one of them is what's called a correlation coefficient. And there is a nice big long calculation for this. Basically, you have to take all of your ordered pairs, the x value minus the mean of that x value divided by the standard deviation for the x. Do the same thing for the y's. You add, multiply those together, add them all up, and divide by n minus 1. It is a very time-consuming calculation to do by hand, but thankfully our calculator will do it all for us. So we don't have to do it all by hand. When we calculate this, we kind of need to know what it means. So ideally, if you get something that's equal to a positive or negative 1, that is a perfect linear relation. And it'll always be somewhere between negative 1 and positive 1. 1 would be like a perfect positive sloped line. Negative 1 would be a perfect negative sloped line. The further your r gets from 1, the less linear it is. So if you get an r value of 0, there is absolutely no linear property to it whatsoever. If we have an r value of 0.6, that's still not great. You know, there's something there, but not a lot. There's no units to it. It is not resistant. What does that mean? We've talked about it with other things, but
It's affected by like dramatic increases.
yeah. Resistant is when like one extreme value doesn't throw it off. That is not the case for R. So if you have one crazy value, it will dramatically change your R value. So this is just kind of an illustration. This is when your R is a positive 1. It's a perfect linear relationship. As it becomes less linear, your R is going to get smaller. So this is more like a 0.9. This one is a positive relationship, but not great. That's 0.4. And then, of course, we've had the same thing with negatives. You know, this one, there's no relationship at all. This one, there's a relationship that it's not linear. So both of those being R very close to 0. So the less linear it is, the further R gets from positive or negative 1. I want to kind of run through how we might do this by hand, and then we'll talk about how to do it on the calculator. Even when we do it by hand, we are not going to totally do it by hand. We are going to use our calculator to get some of these things. So we have to have the mean and standard deviation for each of these variables. So let's go ahead and get that. So if you want to go to your calculator, stat edit, enter these points. And then if you go into your two variable statistics, the mean of my x is 4, standard deviation of my x 2.4495, mean of the y was 10, standard deviation of the y 5.6125. So then if we are going to find our correlation coefficient, we have to do this calculation for each. Phew, splash here. Thank you. We need to do this for each order pair. So for my first point, my x is 1, the mean of the x's is 4, divided by the standard deviation of my x's. I think I'm going to go through and do all my x's first, because then I can just do second enter and bring it back up. I don't have to retype everything. And then when you do the y's, we're doing the same thing, but it's the y value of the order pair minus the mean of the y's divided by the standard deviation of the y's. Does everybody know how I got these numbers? So then, the formula tells us you have to multiply those together and then add all that up. So our third thing, we are going to go through and multiply. So then we add all those up. What'd you guys get? Anyone else get that? Downside of this, any rounding throws it off a lot. You know, if I have 5 decimal places on my standard deviation, my number would be slightly different. There's a lot of rounding as we go through here. We rounded each of these x's and the y's and the final thing. So there's a lot of error in this already. And then the formula says we add all those up and divide by n minus 1. So we take our number divide by n is the number of points. So we have 1, 2, 3, 4, 5 points. So 5 minus 1 would be 4. And we get a correlation coefficient of negative 0.981. Okay. So the question is, do you think this is very accurate? Somewhat, but we have a lot of potential for it to be off, right? Every step we rounded throws it off a little bit. We can also, thankfully, get this on our calculator so we don't have to do it by hand every time. First, we need to go through a process so it will work. On our calculators, we have to turn on the diagnostic feature. You don't have to do this every time, but anytime the memory gets reset on the calculator, it's automatically turned off. So if you're ever trying to find your correlation coefficient and it won't show up, this is why we need to set it. So if you go into second and number 0, that takes us into the catalog. And we are just going to go down until we get to one that says diagnostic on. And it may be on some of your calculators already, but we'll do this just to double check. Everybody find it? So if you'll hit enter, it'll say diagnostic on, hit enter one more time and it says done. So you shouldn't have to do this again unless your calculator gets reset or you get a different calculator.
Mine's up here.
You're welcome. Okay, so now if we go into stat, calculate number 4, the linear regression. X is L1, Y is L2. Go down to calculate. Okay, it gives us a lot of information. Oh, my calculator is different because I didn't do this data set on that calculator. I was using one in my hand. Sorry, that's for our previous example. So if you go through, if you don't have your diagnostic on, then it'll only give you the A and the B, and it won't give all the other stuff underneath. But if you look, this one, we are looking for the R value, and what does your calculator say? Okay, so are we close? Yeah, were we slightly off? Yeah. So the calculator is definitely the better option, and that's what we will rely on for finding these. So it should be pretty easy to find from here on up. So what does that tell us then? If we got a negative 0.9456. Is it a pretty strong relationship? Is this pretty close to 1? Yeah, and it's negative, so it's a pretty strong negative correlation. So if we looked at the equation, it would have a negative slope. All right. There are actual thresholds for how close something has to be considered linear or not. And it has to do with how big your sample is, how big or how close R has to be. If you guys could grab your formula sheets. You never got one? Okay. So the table is only going to give us positive values, just because all the negative is telling us in this case is it's a positive or negative line. So we'll have to compare the absolute value of R to a table. So we are going to go to table 2. It's kind of like back of the second page of your packet. it gives you an N and then a critical value. So the previous example, our N was, how many points do we have? 5? Okay, so we could look at N equals 5, our critical value is 0.878. So anything higher than that would be considered linear. Okay, so the absolute value of ours was 0.9456, so that would be considered linear. And you'll notice as the number goes up, what happens to your critical value? It goes down, because when you have more points, they're probably all going to be less likely to be the same. There's more variability there. So this is kind of our threshold for deciding if something is linear or not. So we just do it when we set. So this is bigger than our critical value, which was 0.78. So that means it's good. If we wanted to do it for our very first example, you guys don't have it in your calculators anymore, but I still have it in mine. How many points did we have in example 1? So, if I looked at my screen here, our correlation coefficient, okay, what is the critical value then? Okay, so you said how many points do we have? 12? So on this, if you're looking when n is 12, our critical value is 0.576. So the absolute value of our R is bigger than 0.576. So is this good enough to be linear? All right, so we can use this table to decide if it's linear or not. Any questions on that? Okay. All I really want to mention now, I have a couple other examples, but I don't know if I really want to go through all of them. Just things to consider. Just because there's a linear relationship, does that mean one thing causes another? No. We've kind of mentioned before, we can say there's a relationship, but that's not the same as saying this caused the other thing to happen. So you have to watch out for the potential of a lurking variable. That's something that might impact both things and cause them both to have a positive relationship or a negative relationship. You can say that there's a linear relationship, but you cannot say one thing is causing the other. Okay, we have not taken everything into example or into consideration. So for example, ice cream sales and crime rates have a very high correlation. Does this mean that local governments should shut down all ice cream shops? I think we could all rationally say no, but why would those have a high correlation? Like when ice cream sales go up, so do crime rates. Why would that even make sense? More money. Even just like in cities, you know, if we looked at how much BBs sold in a day and crime rates, they would go up together. And it actually has to do with heat. When it's hot outside, do you buy more ice cream? And studies have shown that when heat gets worse, crime rates go up. So they're related, but they're not causing one another at all. So we have to watch for those kinds of lurking variables. Do we need to do another example of how to find the scatter plot on your calculator? Okay. So I think I'm just going to go ahead and stop there and give you guys time to work so you can use the calculators while you're in here. So we are going to do those problems. All of your scatter plots you can do on your calculator. If you want to just draw me, like as far as what I want you to show me, very generic, it's fine. You know, if you just want to put a few dots, I know you were looking at it and telling the general trend. most of them are asking you to then like find R or tell if it's a positive or negative relationship. So that's more what